Okay, next unit is Pythagorean Theorem. Essential questions. How do I know which side of the triangle has to be C? And how do I determine if a triangle is right, acute, or obtuse? So let's go ahead and get into it. All right, so the first main idea, of course, is the Pythagorean Theorem. Y'all should all know it by now. A squared plus B squared equals C squared. A represents one of the legs, right there. B represents the other leg, right there. And then C is the hypotenuse. C is the longest side, and it's also across from the right angle, just like that. Some people call it the diagonal side. Pythagorean theorem can only be used with right triangles, so don't forget that. That's really important. So right triangles only. So for example 1, we're going to find the missing side of each triangle. So let me go ahead and start by saying that a squared plus b squared equals c squared. And then we can go ahead and fill in the numbers. So right away, I always like to find where c is first. So it's obvious that we don't know what c is equal to, so I'm going to leave that just like that. A squared is 20, and then b squared can be, 12. So that's going to be 20 squared plus 12 squared equals c squared. And if you just want to do this all in one step, on your calculator, you just take the 20 squared, the square root of 20 squared plus 12 squared, and that'll give you c. Okay, so put that right there. All right, so for this one, we got square root of 20 squared plus 12 squared. And if we hit enter, we see that the answer is 23.3. So that'll be 23.3. All right, for example B, same situation. But this time we see here that we know C is 22. And then A could be 17 and B can be the missing leg. So just a shortcut. If you know what C is, then you're going to have to subtract. I'll show you all the steps, but I'll also kind of. Okay, so here, now since we know what C is, I'm going to go ahead and fill that in. And then A is 17, B is unknown. So we have that. Now, if you want to do the shortcut in one step, just take the square root of 22 squared minus 17 squared, and that'll give you B. So again, if you know what C is equal to, you're going to subtract. If you don't know what C is equal to, you're going to add. Oops, wrong button. There we go. All right, so for this one, oops, didn't press that twice, we get 13.96. Now that 6 is going to round the 9 up to a 10, which, you can't put a 10 there, so we're going to round that 13 up to a 14, so it's about 14. Okay, so that is that. All right, so now moving right along. Next section. The measures of a triangle satisfy a squared plus b squared equals c squared. So basically, if you're setting this up, if they give you 3 numbers and are like, hey, does this make a right triangle? You can prove it by plugging it into a squared plus b squared equals c squared. And if it's true, then it's a right triangle. But if you put a squared plus b squared and that's actually less than c squared, it's going to be an obtuse triangle. And then if you have a squared plus b squared is greater than c squared, it's going to be acute. So I kind of gave you some examples there and there. Okay, so let's see about A. So we're going to do 9 squared plus 40 squared. And we're going to see how it compares to 41 squared. All right, so again, we have 9 squared plus 40 squared, And then for that one, and then we're going to have 41 squared. And let's compare how they look. So we see we get 1681 and 1681. So for both, we get 1,681. So they are equal, which means this is a right triangle. All right, let's try example B. Okay, so same situation. We have 7 squared plus 28 squared. You take the two smaller sides, okay? Make sure it's the smaller ones. And then we're going to compare that to 29 squared. And then we're going to do 29 squared. Okay, let me take a look and see what it says. So 7 squared plus 28 squared is 833. 29 squared is 841. So since the two that we added were less, if we look back up here, then the triangle is obtuse. So again, since the two that we added together were less, that's going to be an obtuse triangle. Okay, and let's move on to C. Okay, now I know this looks crazy, but you have a calculator, relax, it's gonna be okay. So, same situation. I'm gonna actually have to put these fractions in parentheses. If you wanna change that square root of 4 to a 2, that is totally fine. So I'm gonna do that one squared plus, actually let me zoom in some, so I can write this a little bit smaller. Okay, so that one squared. Every time you're squaring fractions, you really need to make sure that you use parentheses. Got to use those grouping symbols. Okay, so we're going to compare these two and see how it turns out. So again, we're going to use parentheses. We're going to hit the fraction button, which is to the left of the 7. And then we got the square root of 4, square root of 4 over 7. And that is to the second power plus parentheses, fraction button. You can just press 2, the square root button, and 3. And then, of course, that's going to go over 7. Click outside of the parentheses, raise it to the second power, hit enter, and that's how you can do that. And then we'll just do 4 over 7 to the second power. Again, you have to use parentheses when you're raising a fraction to a power. Very important. Okay, so let's see what we got. Okay, so for the first one, we have a decimal. For the second one, we got a fraction. So we're just going to need to change the second one to a fraction. And copy. Oh, I didn't mean to copy that. Okay, so I'm just going to put a decimal right there next to the 4. Okay, so now we have that in decimal form. Okay, so it looks like we got the exact same thing. 0.326531 is for both. So that's going to round to 0.3. Okay, so this is a right triangle. Oops, did not mean to click that arrow. Okay, and then last but not least, problem D, line right there. All right, this one's nice and easy. We just have 8 squared plus 12 squared, and we're going to compare it to 14 squared. So coming back to the calculator. Okay, and let's see what we got for both of those. We got 208 and 196. And obviously 208 is greater. Okay, so since those two are greater, if you look back over here at the top, so since the part that we added is greater this time, that's going to be acute. So that's an acute triangle. All right, moving right along. And let me change that to obtuse triangle just to be consistent. Okay, all right. Now, example 3. Determine if the following triangle is right, acute, or obtuse. So we're going to do the same thing we just did, but we got some extra steps in the beginning. So since this is coordinate geometry, we're going to have to use the distance formula to figure out how long each side is, and then we're going to use the rules that are up here after we figure out how long each side is. Okay, to find PQ, we have P and Q, so we're going to plug in those numbers to the distance formula. So that'll be -3 and 3 for the x's, 6 and 2 for the y's. I'm going to go ahead and write these numbers in now first, and then I'll use the calculator in just a moment. So now we have Q and R. So I'm going to have 5 minus -3, and then I'm going to have 5 minus 6. And then for P and R, I have 5 minus 3 and 5 minus 2. All right, so let's check the calculator. Okay, so again, we have square root, and this is going to be -3 minus 3 to the second power plus 6 minus 2 to the second power. And then we're going to have, I'm just going to do all of these at once so I don't have to keep going back and forth. 5 minus -3 squared plus 5 minus 6 squared. And last but not least, 5 minus 3 squared plus 5 minus 2 squared. Okay. So, oops. All right, so it looks like we got 7.2, 8.1, 3.6. 7.2, 8.1, and 3.6. Let me double check that. Okay, and I'm just going, oops. And now I'm just going to go ahead and compare those three sides. So we have the two smaller sides, which would be the 3.6 and the 7.2. So let's add the squares of those. Okay, so that's going to be 3.6 squared plus 7.2 squared. And then I'm going to compare that to 8.1 squared. All right, let's take a look. So we have 64.8. And then we have 65.6. Okay, so the added ones, the a squared plus b squared, was 64.8, and that is less than 65.6. So that should be, remember, we look up here. So since it was less than, that's going to be obtuse. So that is not right, because it just asks if it's a right triangle. Well, actually, it just asks which one it is. So this is going to be obtuse. All right, moving on to the next section, a Pythagorean triple. So a Pythagorean triple is three whole numbers that satisfy this equation. And so here we go. So I'm just going to kind of do a couple for you as an example. So for this one, for example, 3 squared plus 4 squared equals 5 squared, okay? So you got 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, and that is a true statement. So you see what I'm saying? All of these work like that. If we do this one, I'm not going to do all of them, but if you had 5 squared plus 12 squared it should equal 13 squared. So that's going to be 25, right? Because 5 to the second power is 25. And then 12 to the second power is 144. 13 to the second power is 169. And if you add 25 and 144, it does equal 169. So all of these Pythagorean triples work like that. And they're all whole numbers. Because, like, look before, we kept getting, like, decimals. So if I look at these examples up here, we got a decimal here, and we got a decimal here too. We just rounded it up to 14, but it actually came out as a decimal. Usually Pythagorean theorem problems do come out as decimals. So when they don't, when it comes out as a whole number, it's what we call a Pythagorean triple. All right, 3, 4, 5 is a particularly, well, they're all special, but it's called a primitive Pythagorean triple, so this is what I mean. So obviously you got 3, 4, 5. If you take each of those, I'm just gonna do this right here. And let's just say we take multiples, right? So let's say we multiply each of those by 2. So that's going to be 6, 8, 10. So 6 squared plus 8 squared equals 10 squared. Is that a true statement? Well, that's 36. That's 64. That's 100. And 36 plus 64 is 100. Okay, so that works. Let's say that we take the 3, 4, and 5, we multiply by 10. So that's going to be, 30, 40, and 50. That over. So then you'd have 30 squared plus 40 squared, and we're going to see if that's equal to 50 squared. So 30 squared is 900, 40 squared is 1600, 50 squared is 2500, and 900 plus 1600 is 2500, and that equals 2500, of course. So again, you can do that if you just take any of these Pythagorean triples, and if you multiply all 3 of them by the same number, it's still going to create a Pythagorean triple. All right, example 5. An equilateral triangle has a side length of 22 inches. So let's go ahead and draw that out. You already know what's up. Draw the picture if you don't get one. So 22, 22, and 22, equilateral. What's the measure of the altitude? Oh, we've done this. This was the last test. This was the last unit. Altitude goes straight down, remember? Makes a right angle with the base. And then it creates 2 right triangles. So as usual, I'm going to focus on the right side just because I'm right-handed. It doesn't really matter which side you choose, though. All right, so if we do this, we know this side is 11 and this side is 11. So I'm just going to use that to figure out how long the altitude is. I'm going to make that 11b. And of course, you can see that 22 has to be c because that's the longest side. So we have a squared plus b squared equals c squared. And since we know what c is, we can take the little shortcut that I was telling you about earlier and do c squared minus b squared. And then we're looking for a, so that's going to be the one that hangs out by itself. So that'll be 22 minus 11 squared, both of them, and that's going to equal a. I'm going to just do this on my calculator over here so I can go a little faster. And we get 19.1 for A. So the altitude here is 19.1. All right, example number 6, a rectangle, let me draw that, has a length of 12 inches and a width of 10. What's the measure of the diagonal? Okay, and actually I'm gonna just put this 10. You know, it doesn't matter. All right, so it doesn't matter which triangle you decide to use, the top one or the bottom one, but you know that they're both right triangles. So I'm gonna use this one. Doesn't matter. Okay, and if this is if this is 10 over here, then we know that this side is also 10. All right, and the diagonal is gonna be the hypotenuse. It's gonna be C, which is all called the hypotenuse. There we go. And then 10 can be A, sure, why not? And then 12 can be B. A and B are interchangeable, but C has to always be the same, the hypotenuse. All right, so since this time we're looking for C, we don't know what C is equal to, we're gonna add. So our shortcut, we can still do the square root for our shortcut and have A squared plus B squared, so we have to add, and this time we're looking for C. C is the one that stays out here. So if C is the lonely one on the other side of the equal sign, you're gonna be adding. If A or B are, then you're gonna be subtracting. So that's gonna be the square root of 10 squared, plus 12 squared. All right, I'm gonna use my handheld calculator to go a little bit faster. and I get 15.6. All right, next example. BD is the altitude of triangle ABC. Find the perimeter of ABC, and it even gives us a picture over here. All right, so that's an altitude. Boom. All right, we need to find a perimeter. A perimeter means all the sides, right? We add all the sides. I put exterior because some people might be tempted to add one of the inside segments, but you need to add all the exterior segments. Okay. Or all the segments that are going around like that. We need to add those three. Okay, anyway. Let's see. The first thing we need to do is figure out, well, not the first thing, but we do need to figure out how long AB is. We know BC is 41, and we know AC is, what's that, 51? If we add those two together, we get 51, right? So what we need to do is find AB, and we're going to have to use Pythagorean Theorem. So we're going to use Pythagorean Theorem to first figure out this, the altitude. Once we figure that out, we will use these two to figure out that side over there. Okay, so here we go. 41 is C, of course, that's the hypotenuse. 19, we can make that A or B, doesn't matter. And then the altitude, I'm just going to call it A for altitude, why not? All right, so since we're looking for the altitude, we know what C is. We can use the shortcut, right? And do C squared minus B squared. And we don't know A, so A is going to be the only one on the other side of the equal sign. And then we're going to plug in the numbers. So C is 41, B is 9, and let's figure out what A is. All right, and we get 40. Oh, ding, 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 Pythagorean triple. We didn't get a decimal this time. It was just 40. So the altitude is 40. Some of y'all might be like, oh, that's my answer. No, calm down. We're not done yet. So the altitude is 40. So now we're going to use that to figure out this side. So now this is the new hypotenuse we're going to use. So we're looking for the hypotenuse now. So since we're now looking for the hypotenuse, we're going to do the square root of A squared plus B squared, okay? So this 42 is going to be the new B, and we already said that 40 is A. So, and that's going to equal C squared. All right, so that's going to be 40 squared plus 42 squared, and then that's going to give us the hypotenuse. And that's 58. And ding, 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 we have another Pythagorean triple, because again, there was no decimal. This actually equaled a whole number. And oops, I messed up. I'm so sorry. This should be C, not C squared in that first line under the squiggly. Sorry about that. All right, so C equals 58. So AB is 58. And now we need to add up. So let me use a different color highlighter. So we got 58, 41, and 51. Okay, don't forget, I got 51 because we have the 9 over here and the 42 over here, and we're adding all of the exterior sides. So that's going to be 50. I'm going to just put perimeter equals. So perimeter equals 58 plus 41 plus 9 plus 42. Or you can just, instead of putting this, you could just put 51. It's really not that big a deal. All right, I'm going to use my calculator to just add those together. Nobody should be using NSolve for this step. We really need to be mindful of when we use NSolve. All right, there's your perimeter.